Download this code from codegive.com, link in the description below. OK, let's dive into building resilient HTTP applications in .NET using Poly, codenx, and the medium approach. I'll break down the concepts, provide code examples, and explain how these elements work together to create robust and fault-tolerant systems. What is HTTP resilience? HTTP resilience is the ability of an application to gracefully handle failures and transient errors when communicating with external HTTP services, APIs, microservices, etc. In a distributed system, network issues, server overloads, and temporary downtime are common. Without resilience, your application can experience cascading failures and a poor user experience. Why Poly? Poly is a .NET resilience and transient fault handling library that simplifies implementing patterns like retry, circuit breaker, timeout, bulkhead isolation, and fallback. It allows you to define policies that automatically handle these failures, improving your application's stability and availability. codenx, optional, but useful for organization. codenx, or similar architectural approaches, can improve the structure of your .NET project, especially as the application scales. It promotes modularity and separation of concerns, making it easier to manage and test your resilience policies. This tutorial will show examples using a basic layered approach to keep things clear. Medium approach, focus on balanced resilience. The medium approach to resilience suggests striking a balance between aggressive retry strategies, which can overload failing services, and overly conservative policies that might give up too easily. It's about tuning your policies to the specific needs of your application and the services you're calling. Prerequisites *.NET SDK *install the latest .NET SDK. *NuGet packages * you'll need to install the following NuGet packages. *Poly. Poly.extensions.http provides convenient extension methods for HTTP client. Microsoft.extensions.http for iHTTP client factory integration. Microsoft.extensions.dependency injection. 1. Setting up a basic .NET Console application. First, create a new .NET Console application. This example will demonstrate a simple HTTP client that fetches data from a sample API. 2. Creating an iHTTP client factory configuration. The iHTTP client factory is a standard way to create and manage HTTP client instances in .NET. It handles things like connection pooling and DNS updates. It integrates seamlessly with Poly. Explanation * 1 Dependency injection * the configure services method sets up the iHTTP client factory and registers it with the dependency injection container. This is crucial for managing the HTTP client lifecycle. 2 Add HTTP client * the add HTTP client method registers a named HTTP client, in this case, resilient client. You can have multiple named clients, each with different configurations and policies. 3 Set handler lifetime, optional. This sets the lifetime of the underlying HTTP message handler, which handles the actual HTTP communication. Setting a reasonable lifetime, example 5 minutes, allows the handler to be reused for multiple requests, improving performance, but also ensures that DNS changes are eventually picked up. 4 Add policy handler *. This is where you add the Poly policies to the HTTP client pipeline. We're adding a retry policy and a circuit breaker policy. These policies will be executed in the order they are added. 5 Retry policy, get retry policy. *HTTP policy extensions. Handle transient HTTP error, This is a helper that defines what constitutes a transient HTTP error, example 408 request timeout, 5xx server errors, network connectivity issues. *or result, message equals message status code equals system.net.http status code not found. This extends the retry policy to also handle 404, not found, errors. Whether to retry on 404 depends on your application's logic. If a 404 might be a temporary issue, example resource being deployed, retrying might be appropriate. If it's a permanent 404, retrying is probably wasteful. Wait and retry async. 3. Retry attempt equals timespan from seconds, math.pow. 2. Retry attempt, this configures the retry behavior. 3. The maximum number of retry attempts. Retry attempt equals timespan from seconds, math.pow. 2. Retry attempt, this defines an exponential backoff strategy. The delay between retries increases with each attempt, example 2 seconds, 4 seconds, 8 seconds. Exponential backoff is a good practice to avoid overwhelming a failing service. The on-retry delegate logs the retry attempt details. Good logging is essential for understanding and debugging resilience policies. 6. Circuit breaker policy, get circuit breaker policy. HTTP policy extensions. Handle transient HTTP error, same as in the retry policy, defines what's considered a transient error. Circuit breaker async. 5. Timespan. From seconds, 30, this configures the circuit breaker. 5. The number of consecutive failures that will cause the circuit to open. After 5 consecutive transient errors, the circuit breaker will transition to the open state. Timespan. From seconds, 30, the duration for which the circuit remains open. During this time, all requests are immediately short-circuited, i.e., they don't even attempt to call the external service, and an exception is thrown. On break, a delegate that's executed when the circuit breaker opens. Use this to log the event and potentially trigger other actions, example send an alert. On reset, a delegate that's executed when the circuit breaker resets, transitions from half open to closed. This indicates that the underlying service is likely recovered. After the break duration, the circuit breaker transitions to the half-open state. In this state, it allows one request to pass through to the external service. If that request succeeds, the circuit breaker resets to closed. If it fails, the circuit breaker reopens for another break duration. 7. Combined retry and circuit breaker, get combined retry and circuit breaker policy. This is the ideal setup of circuit breaker wrapping retry. Retry will be retrying the request until number of retries finish, and after certain failures, circuit breaker will open and it will stop requesting from the service, giving it time to recover. 3. Running the application. Run the application. You'll see output similar to this, since we're simulating a 503 error. This demonstrates that the retry policy is attempting to retry the request, and after the retries fail, the circuit breaker opens to prevent further attempts for a specified duration. 4. Implementing a fallback policy. A fallback policy provides an alternative response when all other resilience strategies fail. This can prevent your application from completely crashing. Explanation *. Fallback async, this defines the fallback behavior. Fallback value, the HTTP response message that will be returned if the policy is triggered. In this example, we're returning a 200 OK response with a message indicating that the service is unavailable. Asterisk on fallback async, a delegate that's executed when the fallback is triggered. Use this to log the event or perform other cleanup actions. To use the fallback policy, add it to the @HTTP client configuration. Important considerations asterisk. Asterisk idempotency asterisk ensure that the HTTP requests you're retrying are idempotent, i.e., they have the same effect no matter how many times they're executed. If a request is not idempotent, example creating a new resource, retrying it could have unintended consequences. Asterisk context asterisk poly supports passing context data to policies. This can be useful for logging, correlation IDs, or other application-specific information. See the poly documentation for details. Asterisk policy ordering asterisk the order in which you apply policies is important. Generally, you want to wrap the most aggressive policies, example retry, with more conservative policies, example circuit breaker. This prevents aggressive retries from overwhelming a failing service. Asterisk configuration asterisk consider making your resilience policies configurable, example through appsettings.json. This allows you to adjust the behavior of your application without recompiling. Asterisk monitoring and alerting asterisk implement monitoring and alerting to track the performance of your resilience policies. This will help you identify potential issues and proactively address them. Codenx and architectural considerations asterisk. As your application grows, consider adopting a modular architecture like codenx to organize your resilience policies. Here's a basic example of how you might structure your project. iResilience policy provider.cs asterisk. Resilience policy provider.cs asterisk. iExternal API service.cs asterisk. External API service.cs asterisk. Updated configure services in program.cs asterisk. Updated main method in program.cs asterisk. Explanation of the architectural changes asterisk. One policies folder asterisk contains the iResilience policy provider interface and its implementation, resilience policy provider. This class is responsible for creating and configuring the poly policies. This separates the policy definitions from the program.cs file, making the code more modular. Two services folder asterisk contains the iExternal API service interface and its implementation, external API service. This class encapsulates the logic for calling the external API. It uses the iHTTP client factory to create the HTTP client and execute the request. It also handles logging. 3. Dependency injection asterisk the configure services method now registers the resilience policy provider and external API service with the dependency injection container. This allows you to easily inject these dependencies into other parts of your application. 4. Policy injection asterisk in the @HTTP client configuration, we now inject the iResilience policy provider to obtain the policies. This makes the policies more configurable and testable. 5. API service usage asterisk the main method now resolves the iExternal API service from the service provider and calls the getDataAsync method. This keeps the main method cleaner and more focused. Benefits of this approach asterisk. Asterisk separation of concerns asterisk the code is divided into logical modules, making it easier to understand and maintain. Asterisk testability asterisk the resilience policy provider and external API service can be easily unit tested. Asterisk reusability asterisk the policies can be reused across multiple HTTP clients. Asterisk configurability asterisk the policies can be configured through dependency injection and configuration files. Medium approach applied asterisk. The medium approach is reflected in the choice of retry counts, back-off strategies, and circuit breaker thresholds. You need to fine-tune these values based on the characteristics of the services you're calling. For example, *retry count *3 to 5 retries is a reasonable starting point. If the service is known to be unreliable, you might increase the retry count, but be careful not to overload the service. *backoff strategy *exponential backoff with a jitter, a small random delay, is a good way to avoid thundering herd issues. *circuit breaker threshold the number of consecutive failures before opening the circuit breaker should be high enough to avoid false positives, but low enough to prevent prolonged outages. *break duration the duration for which the circuit remains open should be long enough for the service to recover, but not so long that users experience unnecessary downtime. Conclusion By using Poly, HTTP client factory, and a modular architecture, you can build highly resilient .NET applications that can gracefully handle failures and transient errors when communicating with external HTTP services. Remember to monitor your resilience policies and adjust them as needed to optimize your application's performance and availability.